All right. Okay. So here's a little history lesson. Okay. I've been telling this in broken speech throughout, but let me give you the most informative conversation about Git that you will ever get. Get it? All right. Let's do it. Little impromptu story time. So once upon a time, two people were coding. Oh, how lovely. It is amazing what humans can do when they figure out how to work with other humans. As another tangent to the already tangent we are on, the most important thing for you to learn to do properly in school is group projects, because all you will ever do in your work life is work with other people. Figure that out. That's a really important skill to have. So, once upon a time, two people had figured out how to work with one another and were working on code. And of course, there's this problem if we're both trying to touch the same file at once. And that is the official term. You don't work on the file, you touch it. So you're both trying to touch the same file, but only one of you is allowed to do it at once, because what you don't want is what's called a conflict, where you're both editing around in the same area, and then when you go back to try to squish everything together, you're kind of screwed. You would probably have to both sit down and work out that conflict together. And so, for a long time, the way that software was done was literally like, dude, don't work on this file. I'm the one working on this file. And you would just be like, don't do it. And there was like significant ways of trying to make sure you didn't fuck each other's stuff up. And this is where a beautiful thing called Git comes in, where you have your what's called the master branch. Now, this fist that represents the master branch is the universe. It is everything that is officially in your product. And if you want to work on that, what you do is you make a full copy of it, what's called a branch. You branch from master. You fork a branch from master. Isn't that a sexy way to say it? You don't say you make a branch, you fork it. Am I right? Engineers, back me up on this, right? It's for the same reason that in math, if it's t sub 0 and t sub 1, we don't call it t sub 0, we call it t naught, because it sounds cooler. You fork a branch because it sounds cooler. Okay, so I got master branch, and let's say I want to work on some branch that does something like Mario physics, so I'd call it something intelligent like Sean Mario physics. That would be the name of the branch that I was doing. Or Sean new jump physics. Something like that. Sean, so that way they know it's my branch. And then what it does, so they know what it does. Why would I not do that? So I'm working on my branch. I do stuff until I feel like it's in good state, till I like the code. And then what I do is I mash it back together. I do what's called a merge onto master. And what Git is incredibly good at is figuring out where it's supposed to merge and how it's supposed to merge. So that way, if you and I are both working on the same chunk of code, it has a methodology for resolving that and for bringing people in and making sure that they look and resolve that properly. And it just creates this wonderful thing, for instance, in our work environment where I can be doing design things like balance changes or using our unit editor to make new units and abilities or tweaking the map, and I can do that. And then the art team can be working on art stuff, and they can be checking out branches, modifying art, and merging that back in. Engineering can be checking out stuff, doing performance fixes, checking that back in, and doing that all in an oh-so-lovely fashion. So the important thing is that these branches are separate. You're actually working on your own separate branch. And so what's happening is master's continuing to update, continuing to do awesome things while you're working on your branch before you reinsert it. Because, again, another thing you don't want is if you're working on your stuff and the world starts changing. That's why you merge out of master and then you merge it, or excuse me, you branch from master and you merge it back in. So there's all these conveniences that get put in there. So, for instance, there is what is known as a commit. I'm working on my code, and let's say I do two things. Let's say I work on Mario's sliding physics, and then I work on Mario's jump physics. These are the two tasks I have. A commit is a logical chunk of work that I will give a description, like commit number 1, fixed the slidiness bugs with Mario's movement. Commit number 2, tuned the jump physics to allow Mario to land on platforms more easily. And so that way someone can go and say, oh, this is Sean's branch where it looks like he's doing physics stuff. And if I look at the specific commits, I see not only what he's done, but where he's done it, and a good description of that. Oh, it's so wonderful. It's such a beautiful thing. So there's just this log of what everyone's been working on. It's so amazing until you learn about a command called git reset hard. So here's what happened today. Here's what was happening today while I was working. Often when you change some of the core files that you actually are wanting to change, you change some of the other ones too, just sort of incidentally. So like, let's say you're working on Mario's jump physics. That's the main thing you want to actually be working on. So you fiddle with the level a little bit to just get some platforms there so you can test the jumping. You don't want to keep these changes on the level. You totally don't. This is throwaway stuff. You actually specifically don't want to keep that. So what you'll do is you'll do a git commit and add all the files related to jump physics. And then you will say git reset hard and get rid of everything else, or git clean-f or what, any of those other things, right? It's a command. Git reset says set everything that I haven't specifically committed back to normal. So here's what I did. I did a whole bunch of changes. Well, it wasn't exactly changes. It was, I was doing a whole bunch of tweaking. I would tweak, and then I would test and tweak and test and tweak and test, and I had it really good. And I typed in git add, and I was like, yeah, add it all in, I'm done. And I pushed it. And pushing is trying to get it back into the master branch. I was going to have someone review it, and it wasn't showing up. And I looked, and I saw the files that I didn't want there. So I was like, all right, let's git reset. And I git reset and realized that I had added the files that I wanted to commit, but I just hadn't committed them. So in other words, I just cleaned everything. I just did a whole bunch of work and then typed in every single thing I was supposed to do except git commit, and then did git reset hard. And just cleaned it. And let me tell you, that feels amazing. That's like preparing a huge meal, setting the table and being like, all right, here we go. And then it's just disappeared. And you're like, oh my God. Now I understand why the pull request wasn't showing up properly. I pushed something with no commits on it. I forgot to commit. Ooh. Anyone else ever done that? Anyone ever done git add, git push origin branch name? Oh, I don't need that. Git reset hard. Whoops. Anyone ever done that? That's what I did. And fortunately, I pretty much knew what I needed to redo, so it only took me like 45 minutes. It's just this insane thing. Yeah, no, I typed git status. I saw the green block of files to be committed. I saw the orange block of files unstaged, not ready to be committed. And I was like, tight. I think the weirdest thing is that I pushed a branch with no commits and it just didn't show up on GitHub. And I was like, well, that's fucking odd. What? Am I too far behind master? Like, it never occurred to me that the reason I wouldn't see it is the only reason you never see it. So good.